Okay, so think about like the last piece of tech you used, right?
Yeah.
Could be your phone, laptop, heck, maybe even a smart coffee maker.
Yeah.
Seems pretty simple on the surface, right? But what if I told you every single one of those things, no matter how basic they seem, they all exist for a very specific reason?
You hit the nail on the head there, and that's really where our deep dive kicks off today, exploring the fundamental purpose, the function behind all these computing innovations that are just so intertwined with our lives now. We really want to unpack what drives their creation and how they actually do what they do, the nuts and bolts.
Yeah, and we've been going through some really insightful educational stuff to sort of break this down for everyone. So our goal today is to help you guys walk away with a much clearer grasp of the why, the how, behind the tech you use all the time, every day, constantly.
Absolutely, and to achieve that, we'll be zeroing in on three key areas. First, we're going to unpack the driving purpose, the why behind these computing innovations. What was the need? What sparked that development in the first place? Then we'll shift gears and examine how these innovations actually work. We'll focus on the flow of information, particularly inputs and outputs. And finally, we'll explore the crucial role of program documentation, that often unseen but absolutely essential part of bringing these technologies to life and keeping them running smoothly.
Yeah, get ready for a little perspective shift here. But first, we got to start with the basics. Why do these computing innovations exist? Well, everything we've looked at points to one key idea. Every single innovation, no matter what it is, it's developed with a very specific purpose in mind, kind of like a guiding principle.
That's spot on. And generally speaking, that purpose boils down to one of two things, right? Either solving a problem, like streamlining something, making it more accessible, or pursuing a specific interest, expressing creativity, enabling us to do things we couldn't do before, pushing boundaries.
Makes you think, right?
Mhm.
It's not just some abstract concept. Understanding that initial why, that core motivation, actually makes developers so much more effective. It helps them build innovations that truly resonate, meet a real need, or fulfill a desire. And the stuff we've been digging through, it categorized these innovations into three main areas. I found it super helpful just to get my head around the sheer variety that's out there.
Yeah, it's a good way to look at it. Thinking of them as applications, physical devices, and systems, it gives us a good framework for understanding their scope and impact.
For sure, absolutely. So first up, we've got applications, right? These are your games, your social media, all of those tools you use at work or just to manage your life. Honestly, can you imagine a day without them? How different would our routines be?
Oh, massively different. They've become so deeply integrated into how we communicate, entertain ourselves, get things done. It's hard to even remember what life was like before.
Right. Yeah, exactly. Then we move on to physical devices. And this is where it all becomes tangible. Think about your smartphone, your laptop, tablets, even the growing world of smart devices.
Yeah.
All those gadgets popping up in our homes. And then you have wearables. Things are getting seriously sophisticated on that front.
Yeah, wearables especially, the evolution there is mind-blowing. Like, remember those first clunky cell phones that revolutionized communication? Now we've got interconnected smart ecosystems in our houses, and we're strapping on smartwatches to track our health, even using devices like pacemakers and insulin pumps to literally save lives. That's the impact we're talking about.
It's true. The pace of change is insane. And those devices are literally extending our abilities in ways we couldn't have dreamed of not so long ago.
Absolutely. It's like science fiction becoming reality. And then we have the category that often flies under the radar but is absolutely essential, the systems. Think e-commerce platforms that power online shopping, cloud services that store our data, even something as basic as email, all working behind the scenes.
Yeah, you're right. We kind of take them for granted because they're not front and center. But think about it. E-commerce has totally transformed how we buy and sell stuff. Cloud services underpin so much of what we do online. And email, even with all the new ways to communicate, is still a workhorse for so many people. They're the infrastructure, the backbone of the digital world.
Couldn't have put it better myself. And when we want to really understand the purpose behind a specific computing innovation, we need a good way to break it down.
Right.
And the resources we looked at had some great guiding questions for that.
Yeah, these questions are key. First up, why does this computing innovation exist? Super simple question, but it forces you to go back to the fundamentals. What's the motivation? What's the driving force?
Exactly. Then you've got what problem or problems does it solve? And it's important to remember, as they clarified, that problem doesn't always mean something negative. It can just be a need or something that could be done more efficiently.
Yeah, that's a crucial point. Innovation isn't just about fixing what's broken. It's about finding ways to improve, to explore new possibilities.
Absolutely. And the last guiding question really gets to the heart of the transformative power of these innovations. It asks, what does it allow us to do that we couldn't do before?
So let's put these questions to work. Let's walk through a few examples, right? Think about social media apps. Why do they exist? Well, to connect people, no matter the distance, and to give people a platform to share and keep track of their experiences.
Exactly. And what needs do they address? They break down geographical barriers, right? They provide a sense of connection that goes beyond traditional communication, like phone calls or letters. And the archiving aspect, that's significant. Being able to look back at past posts, it creates a digital footprint that just wasn't possible with older methods.
Right, and then think about e-commerce. Its primary purpose is to make shopping easier, and maybe save people some money. It lets you browse and buy from home,
Yeah, it eliminates the need to travel to different stores, and it makes comparing prices way easier.
The time-saving aspect is huge, and it opens up access to a wider range of goods and services. It's really changed things.
For sure. Now, how about a digital assistant device? Its main purpose is hands-free control, enhancing safety, especially while driving, and it just makes multitasking easier.
Yeah, and the problem it solves is potential distractions and inconvenience, those times when physically interacting with your tech is a pain or even dangerous. And like the source mentioned, it might not always be a necessity, but it definitely offers major benefits.
Absolutely. So we've covered the why. Now let's dive into the how. How do the programs within these innovations actually work? Let's start with inputs and outputs.
All right, so inputs. These are essentially pieces of data that we feed into a computer so a program knows what to do, right? And the source made a point about events being the trigger. An event is an action that provides the input data.
That's right. An event, it's any occurrence that kicks off the flow of information into the program. And these inputs, they come in a surprising number of forms.
Yeah, they really do. So you've got your tactile or touch inputs like tapping on your phone, swiping through photos, or even that force touch thing, adding a whole other dimension to touch.
And then there's audio input, speaking to your smart assistant, right? Visual input, like facial recognition to unlock your phone. Text input, like typing, even pushing buttons on a remote, or the power button on your device. It's all input.
Crazy how many ways we communicate with these devices, huh? And this whole event-driven programming concept, that was an interesting one. It's not the straightforward step-by-step process I thought it was.
Yeah, event-driven programming, the program doesn't just run through a list of instructions in order. Sections of code are set up to execute only when certain events occur.
So it's more like a bunch of reactions waiting for their specific trigger, not just a recipe you follow line by line.
Yeah, exactly. And the source gives some good examples of user-initiated events: clicking a mouse, tapping or swiping on a screen, force touch, pushing buttons, typing, speaking a keyword.
All actions that generate input, and the program reacts accordingly, right? But here's the thing. An input doesn't always lead to an output, does it?
You got it. Like tapping your phone when it's off, input, but no response. Or saying the wrong wake word to your smart speaker. The audio is there, but it's not recognized as a valid trigger.
Right. The program has to be ready to receive and process that input. Okay, so let's flip the script and talk about program outputs. This is the information the program sends back to a device after it's processed the input or based on what it's currently doing.
Outputs engaging our senses in all sorts of ways.
For sure. We see visual outputs all the time. Changes on our screens, we hear audio outputs, music from our speakers, a voice assistant responding. We even feel tactile outputs, like phone vibrations or controller rumbles. And of course, there are text outputs, the words and information we see.
All different ways the program communicates back to us. So let's break down the process, how an event turns into an output, what connects those two.
Yeah, how does it all work?
Okay, first, there's the action, right? The user does something, or sometimes another part of the system does. This triggers an event. Remember the smart doorbell. Someone presses the button, that's the action. The signal that's sent, that's the event.
Right, so the doorbell press is the event, and then what happens inside the program?
The program then goes and finds the specific code designed to handle that particular event, in this case, doorbell pressed. It's not running through all the code from top to bottom, just the part that's relevant.
Like a targeted response.
Exactly. And once it finds that code, it executes those instructions. This could produce an output, like a notification on your phone, or even trigger other events within the system. Maybe the doorbell ring event makes the program access the camera, which then sends you a visual output.
So a chain reaction. One little input sets off all these internal processes, and we end up seeing, hearing, or feeling a response.
Precisely. The code doesn't run in a predictable sequential order. It's all about reacting to those triggers.
Okay, so we've got a decent handle on the purpose and the function. Now let's shift gears and talk about what goes on behind the scenes, the creation process. We're talking program documentation. It's often overlooked, but it's crucial.
Yeah, the average user might not even know it exists, but it's absolutely essential for building and maintaining reliable software. So, what exactly is program documentation?
It's essentially a written record of everything about a program. It outlines the purpose, explains how the different parts work, like specific code sections and event handling, even details about its development history, who worked on it, what decisions were made.
Like a user manual and a developer's diary all rolled into one. And the source talked about program specifications. What are those? Program specifications are basically detailed descriptions of all the core aspects of the program. We're talking functions, the procedures and methods used in the code, descriptions of specific code segments, how events are handled, and what outputs they produce. It even includes the program's development roadmap and potential interactions with other software.
Sounds incredibly thorough. It's not just what the program does, but all the details of how it does it and how it fits into the bigger picture. And I noticed they mentioned including the names of contributors, the authors, in the documentation. Makes sense, especially for big projects.
Yeah, it gives credit where credit's due and creates a point of contact if there are questions later on. Now, when does all this documentation happen? Is it just something you do at the end?
Actually, it's an ongoing process. It starts right at the beginning when they're defining the initial specifications.
Yeah.
What problem are we solving? What are the core features? This early documentation helps solidify the vision and set clear goals.
That's right. It's not an afterthought. It's woven into the entire process.
And then it continues as they're actually writing the code. I can see how it would be helpful keeping track of decisions, explaining complex parts of the code, just staying organized. It's like leaving a trail of breadcrumbs for yourself and your team.
Exactly. Programmers often write documentation right in the code as they go. And then, once the program is finished, there's usually a final stage as review and refinement. They make sure the documentation accurately reflects the final product, update the specifications, and formally credit the contributors.
So all this effort put into documentation, it's got to have some benefits, right? The source mentioned improved programming efficiency as a key advantage.
Absolutely. Good documentation, especially notes explaining the logic behind the code or why certain design choices were made, it saves a ton of time when you revisit the code later or when someone new joins the project. It's way easier to pick up where you left off or help others understand your work.
And it makes testing and refining the program more effective too, right? If you have clear documentation outlining what each part of the code should do, it's easier to find and fix bugs.
Right. Good documentation serves as a reference point, ensuring that the program functions as intended. And maybe most importantly, in the long run, it simplifies the process of maintaining the program and fixing problems that crop up after it's released.
If a bug pops up or a new feature needs to be added later on, comprehensive documentation makes understanding the code and making changes a lot smoother and less error-prone. So how do programmers actually create this documentation? The source talked a lot about comments within the code.
Comments, they're essential. They're notes that programmers embed directly in the code itself. The key thing is, these comments are for humans to read. They have zero impact on how the program runs. The computer just ignores them.
So it's like leaving little explanations or reminders for yourself or for anyone else who might work with that code later on.
Right. When you've got complicated sections of code, comments can help you remember your thought process or explain what a particular function does. And in a team environment, clear comments are vital for communication. It makes sure everyone's on the same page, understanding how different parts of the program work.
Yeah, good communication is key, especially on big projects. And the source gave examples of how comments are written in different programming languages, which was cool to see the different approaches.
Yeah, it's interesting. Like in Python, you just use the hashtag symbol, the hashtag at the beginning of a line, and everything after that on that line is treated as a comment.
And then you have Java, which has a few different ways to do it. You can use two-side for single-line comments and to enclose multi-line comments. And then there are documentation comments that start with end and end with.
And a lot of other text-based languages like JavaScript, C, C++, Inc., and Swift, they follow a similar commenting style to Java. And then there are languages like XML and HTML that use ACK and ACK tags to mark comments.
And some less common languages like AppleScript and Pascal, they have their own syntax using ACK. It shows that the need for explanations within code is universal, even if the way you do it is different.
For sure. And it's important to remember how commenting works in visual, block-based languages. These are often used to teach programming basics. The source mentions Scratch and App Inventor as examples.
Right. In Scratch, comments are little text boxes attached to code blocks, and you can even minimize them to keep your workspace clean. App Inventor uses a question mark and a speech bubble for comments, which you can also collapse. It's a more visual approach, but the goal's the same. You're adding explanations to make the code easier to understand.
Exactly. Even in those drag-and-drop environments, documenting your work is essential. Okay, so let's bring it all together. What are the main takeaways from our deep dive today?
Well, first, we learned that computing innovations aren't just random creations. They're driven by a specific purpose, whether it's to solve a problem, address a need, or open up new creative possibilities. Then we explored how these innovations work. It's all about the interplay between inputs, which are often triggered by events, and the outputs that we experience in different ways. And finally, we uncovered the crucial, though often hidden, role of program documentation. It's essential throughout the entire life of a piece of software, from the initial planning stages to ongoing maintenance and team collaboration.
And if you think back to the goals we set out at the beginning, you should now have a better understanding of the why behind the technology you use. You should be able to recognize different types of inputs and outputs. And you should understand the importance of program documentation, even if you never see it directly.
So here's a thought to chew on. Now that you know more about the purpose and inner workings of all this tech, does it change your perspective? What problems are being addressed, what interests are being pursued by the apps and devices you use that you maybe hadn't considered before?
It's worth thinking about, right? And even though you might not see it, remember that careful documentation played a key role in bringing those digital tools to life.
Absolutely. And if this has piqued your interest, why not dig a little deeper? Maybe research the purpose, the development process behind a specific computing innovation that you find interesting. You might be surprised by the level of detail and thought that goes into even the simplest tech we use every day.
You never know what you might discover.